A short lifetime ago, what you're about to witness would have been the stuff of science fiction. Somehow today, we've all begun to accept it as normal, as commonplace.
Air Canada 575, stay with me until you make the left turn onto Delta 5, please, then contact 2207 with your location. Yeah, 575, Roger.
For all we're about to do is take a commercial flight across the Atlantic. We'll sit in a long metal tube with wings and go from Toronto, Canada to Frankfurt, Germany. It'll take about 7 hours.
Air Canada 876, runway 24 left, and it's a Leicester 2 standard instrument departure. Hold short of Charlie taxiway for sequence.
We'll travel at just under the speed of sound. We'll eat dinner 10 kilometers above the ocean and watch a movie while rushing into someone else's morning at 800 kilometers an hour. By breakfast, most of us will be tired, grumpy, disheveled, and in desperate need of a shower. That is, of course, if everything goes the way they planned it. What's even more amazing is that we will not be alone. On any given night, there'll be 125,000 people shuffling back and forth over the North Atlantic on 500 different flights. The technology and the human resources that go into just one of these journeys is staggering. And it's that technology and the people who operate it that we'll be examining tonight, as together we take just another ordinary flight across the sea on Air Canada 876 to Frankfurt.
Air Canada 876, call 219 now, tell them you're approaching Delta Victor.
The North Atlantic is important to us. It's over $1 billion business per year for us.
Terminal 2, Terminal Officer Bravo, Security Operations.
Security will not be compromised in any way at the airport.
Canadian 824, traffic 2 o'clock, 5 miles.
I think there's a lot of stress in everybody's job.
Another one off your right side to northbound St. Aug.
There's a lot of stress being a housewife, staying at home with 2 kids.
You're flying 400,000 pounds of metal down, a 2-mile runway, and you wonder how it all happens sometimes.
Over the last 24 hours, this Boeing 767 has been airborne for almost 15, and it's about to go again for another 7, flying from Toronto to Frankfurt. This, say the mechanics, is normal. It is not only a workhorse, it is a technological wonder. And to those who know about these things, this plane is one of the great aviation icons of our time. Just look at it for a minute. Its wings are a blend of alloys and various metals that span 47 meters across. It's 55 meters long and its tail stands taller than a 5-story building. Fully loaded, it weighs 175,000 kilograms. It can fly non-stop for more than 12 hours and provide relative comfort, hot meals and fresh coffee for 200 people. And you can pick one up for a little over $120 million. Perhaps the most lucrative and most competitive international airline routes in the world are those over the North Atlantic. On any given Sunday, there'll be 1,000 flights buzzing back and forth. Air Canada has 3 trips a day between Toronto and Frankfurt. Flight 876 will be one of them, carrying the 200 of us who've placed our lives and our luggage in the hands of this anonymous network of people and technology that we'll never see, but who are already working furiously on our behalf.
2899. Oxygen 502 again, radio standby. Standby frequency of primary is 5616, secondary 2899, and also be advised.
Not only will we not meet the people on the ground, chances are we'll never even see the 2 people who are flying us between the continents. We'll probably never meet Captain Jim Guild or know why he chose to become a pilot.
I started my interest in aircraft probably at 5 or 6 or 7 years of age, very early.
When I was finished school, I was fortunate in that I had an opportunity to enter into the military and fulfill that dream of flying aircraft. Had I not done that, I'm not really sure what I would have done.
Flying beside Guile tonight will be First Officer Chris Granley, who, it appears, had little choice when it came to professions.
It's almost hereditary in my family. My father flies, most of my brothers and sisters fly, aunts and uncles fly. Everybody flies and has been for quite some time. It's almost, sacrilegious not to be a pilot in my family.
This is somewhere most of us will never visit, the briefing room where the pilots gather to review their various flight plans. After all, if you're flying just one of the 500 aircraft sandwiched together on a complicated multi-lane highway 34,000 feet in the air, it makes sense to have a plan. Here, Granley and Guile will pore over the tools of their trade: the weather, the flight path, the aircraft's weight and fuel load. They'll check it out in a language that almost resembles English.
The route. You want to check the ICAO? Sure. I'll read it off to you here. Upper November 523 Cork. Okay. Upper Lima 607 Evran. Upper Lima 607 Conan. Okay. Upper Golf 1 November Tango Mike. Yep. And the route is 1 Whiskey. Yeah, it's the same. Okay. Okay,
Flight 876 will carry 63,000 litres of fuel, about $18,000 worth. They expect to burn about 80% of that en route, and it's become a matter of professional pride not to eat into the surplus.
52 at 15. As a group, the pilots pride themselves in being able to get an aircraft from point A to point B safely, number one, and number two, with the least fuel burn possible. Okay, track Tango. Chris starts at Raffin. The fuel resource is a huge resource in our airline. It's probably the number 2 expenditure by the corporation after wages and benefits. It would probably be for Air Canada in a given year, it would be in excess of $600 million for fuel. So of course it's a resource that has to be managed very carefully. Even a 1% saving over $600 million is a very large amount of money. 48 at 30. Good.
Both men have already survived the scariest part of their day, for just driving to the airport is 20 times more dangerous than flying their 767 to Europe. All they have to do now is deliver the multi-million-dollar aircraft, its passengers and cargo, safely across 4,000 kilometers of the North Atlantic in the dark, and try not to worry too much about the responsibility.
There's a great deal at stake, both financially and emotionally and everything else that goes with it. But when you take it, the whole big picture in and think about everything that's gone into not just the airplane, but that particular flight and all the people and what they've got invested in it and their families and everything, you just couldn't do the job, I don't think, if you just looked at it that way every time.
The role of the captain is to ensure that the flight is conducted in a safe manner. That's the primary role. As far as the other groups of individuals that are behind the scenes working, as a captain or as a pilot on the aircraft, you must have faith that other people are doing their job as they are supposed to be doing it.
As Granley and Guile move to fly across the Atlantic, they and we are following in the airborne footsteps of legend. A legend that came to life one night in May 1927. For on that night, there was only one lone beacon of light puncturing the darkness between North America and Europe. The British aviators, Alcock and Brown, had made the first two-man trip across the ocean in 1919. But it was on the 27th of May 1927 that the world held its breath as 25-year-old Charles Lindbergh made the first solo transatlantic flight. The flight captured our collective imagination and ushered in the real age of commercial aviation. For after Lindbergh, it seemed that the skies belonged to everyone, and everything was possible. Just 15 years later, there were more beacons, more lights. The world was at war, and planes got bigger, more powerful, as they ferried troops and supplies across the Atlantic to Britain. But it was after the war that we began our love affair with fast and luxurious airliners and fast and attractive stewardesses. By the late 1950s, anyone from anywhere in North America could arrange to cross the Atlantic in a single day. Anyone with money, that is, for flying was still a luxury. Now, for many of us, it's a necessity. Air travel, once unthinkable, has become nothing unusual. We now commute by air. It's affordable, comfortable, and safe. Chances of being involved in a fatal accident are now 1 in 8 million. But as passengers, we still don't have any real idea of that complicated network that makes it all work. And if everything goes according to plan, that network is just about to go into action to launch Flight 876. No matter how many flights you take, there's always this one simple and rather frightening question, which any normal, rational person has to ask, and it is this. If fully loaded with 200 passengers and crew and cargo, this Boeing 767 weighs 175,000 kilos, and if, as all the books say, the engines only provide the power to go forward and not up, how does this thing fly? The answer, we are told, lies here, in the design of the wings. This is where it starts to get too complicated for mere mortals, but essentially it's a marriage of physics, engineering, speed, and maybe a bit of voodoo. Wings on commercial airliners all have the same basic design principles in common, and all rely on Newton's law, that for every action there's an equal and opposite reaction. These wings are designed to act as a type of pump. Air coming over the back of the wings is forced downwards. This has to, according to Mr. Newton, exert that famous opposite reaction, and when something goes down, something else has to go up. The faster the engine pushes the aircraft forward, the more air is deflected downwards. Increase the angle at which the wings meet the airflow, and voila, we have liftoff. For aviation people, it's simple physics. For the rest of us, it's the power of prayer. Once we're in the air, hydraulics are used to manipulate various control surfaces which disrupt the airflow and change the flight's direction. The elevators on the tail control the pitch angle. When they are up, the airflow pushes the tail down, and Mr. Newton again, the nose goes up, taking the plane higher. When the elevators on the tail control are pointed down, the opposite happens. The tail goes up, the nose goes down, and the plane starts to descend. The same theory works to control all three axes of flight. The elevators for the pitch angle, the ailerons on the wing to make the aircraft bank right or left, and the rudder to keep it aligned and on course. That is, of course, if it gets off the ground in the first place. And that's where the ground crew come in. Every time a plane lands, it undergoes a routine check. On Flight 876, Herman Mailer is overseeing the checking operation.
We're generally doing a good walk around on the aircraft. We're looking at fuselage condition, landing gear. We're looking for any kind of fluid leaks around the gear, any kind of leaks in any general area where there might be a flight control surface or under the wings and belly area where the fuel cells are. We're checking the wheels and brakes, making sure that the tires are in good condition, that there's no cuts or any abnormal wear on the tires, and of course the brakes.
Although you may not want to hear this, the truth is that not everything on every commercial airliner works perfectly all the time. On Flight 876, it's probable that some things aren't working at all. A modern airliner has thousands of different components. The odds of them all working at their peak are not great. Comforting, isn't it? The 767, like all other aircraft, has a minimum equipment list, or MEL, which gets checked off before the plane can leave the ground. It also keeps track of maintenance schedules and when various parts should be replaced. And as long as any plane meets the minimum equipment list requirement, it can fly. Don't forget, almost every component has a working backup, so it's not as bad as it sounds.
An item like an electrical generator on an engine, we can fly it with one generator out, because the other engine has a generator, and we also have a generator on the APU. Is an A classified as an A deviation, which is a 3-day deviation. It has to be rectified within the 3-day period. If we find during the service check a major hydraulic leak, we have to address the aircraft. We absolutely have to do something about it. We put an estimate on the aircraft and we fix the snag.
If one of these engines was to fail on takeoff, the 767 is designed to still get into the air, turn around, and land on the one remaining engine. Our major hope now is that they won't have to do that, and both engines, each with 50,000 pounds of thrust, are ready to take Flight 876 to Frankfurt. Toronto's Lester B. Pearson International Airport serves as Air Canada's main hub. 28 million passengers a year go through here. 96 flights an hour. That's one every 40 seconds. It employs 18,000 people, seems to work perfectly well, and within the next 10 years is scheduled to be replaced. It isn't big enough. It's going to be turned into a new airport capable of handling 140 flights an hour and processing 50 million passengers a year. This in a country of only 30 million people. Air Canada now has about 500 flights a day coming in and out of Pearson. Juggling available aircraft and delivering them to their destinations is the domain of another group of people we'll never see, the flight dispatchers. It's their job to know everything they can about each individual flight, right down to the number of people with connections. Dan Meekin is the flight dispatcher for Flight 876.
This particular flight is what we call a TMM, or Total Mission Management Flight. We're trying to get the flight to Frankfurt on time. We have on 876 today 75 passengers that we want to get in there as quickly as we can so they can get on their subsequent flights and go to wherever they want to go.
Meekin has some pretty sophisticated software at his fingertips. It takes everything into account: the winds, the type of aircraft, the traffic, the cost, the fuel consumption across the various North Atlantic tracks, known as NAT tracks. His job is to put all that together and then come up with the most cost-efficient way to get us to Frankfurt.
What I put in has come up with a number of analyses for all the NAT tracks that are operational eastbound tonight, plus the minimum cost time, minimum time track, and minimum fuel time. I'm going to compare the minimum time track and see where it goes in relationship to the NAT tracks. In this particular case, we have most of the tracks fairly far south to pick up the west to east jets. So the idea being, if you pick up one of those tracks, you should get to Europe fairly quickly. I'll file him with a particular track. We'll have a look at the analysis and find out which one that's going to be. In about an hour or so, Gander ATC is going to tell them exactly what they're going to be able to give them. It's fairly complicated. And of course, you're trying to get everything done as quickly as you can.
Plotting the route an airline will take is just like planning a car trip, except that the highway we're on is just a line between two spots, about 34,000 feet in the air. These airways are structured between radio navigation aids known as VORs. Think of them as lighthouses which send out two separate signals. The aircraft's navigation radio measures the time difference between the signals to make sure it's online. If an aircraft simply follows a straight line from one VOR to another, it can remain on an established airway all the way to its destination. If the flight plan calls for them to get off the airway, they can also navigate between established waypoints. These are mapped latitude and longitude points identified where two radios from two separate VORs intersect. In effect, these various radio signals create a huge highway system in the air, invisible to us, but crucial to all air travel. Every country Flight 876 passes over maintains and operates its own navigational network, and passes the cost of that back to the airlines.
Probably the highest cost we have right now, other than possibly fuel, are overfly charges. Over the United Kingdom is expensive. If we can get to Europe, in this case Frankfurt, by avoiding the United Kingdom, it would be great. We wouldn't have to pay the rather high overfly charges. Fortunately, it's kind of hard to get from the North Atlantic to Germany or France without going somewhere near the United Kingdom.
Everything about the airline business, it seems, comes back to the dollar, or in this case, the pound. Interestingly enough, the flight plan Dan Meekin finally settled on for 876 was not the computer's first choice. His new plan will mean moving faster and burning more fuel. It'll actually cost more, but it makes sense to Meekin.
Okay, I've got a flight plan here on what we call the North Atlantic Track Tango, and the North Atlantic crossing is going to be Mach 840, and just in comparison, at Mach 800 on the same route, we're going to pick up about 15 minutes. We'll be burning more fuel. In fact, we'll have a look at it and see what the difference is here. As a matter of fact, it's going to cost about $1,300 to do that. And offsetting that is the cost of trying to accommodate 75 passengers in Frankfurt when they've missed their connecting flights. And we're responsible for them.
When Dan finishes his flight plan, he'll email it to the various air traffic control centres between Toronto and Frankfurt. It'll be their job to fit us in with all the other flights from all the other airlines, each of them vying for the best possible route for their particular aircraft. If anyone in the entire system, from Toronto to Frankfurt, doesn't accept his plan, they'll let him know right away, and he'll have to start all over again. In this case, however, no news is good news, and it appears that we on Flight 876 have a route to Germany. Just 20 years ago, the idea that a twin-engine aircraft could be used to cross the Atlantic had senior pilots and safety experts in an uproar. They claimed the whole notion was absurd and dangerous. What if one engine failed? The Federal Aviation Authority had safety regulations in place since the 1950s, limiting the range of twin-engine craft by insisting they had to follow a route that kept them within 1 hour of land should they have to fly on only one engine. But in 1981, as the technology advanced, there was a push in the States to deregulate the airline industry and open the whole business up to more competition. Airlines lobbied the FAA to change the rules for twin-engine planes, asking them to extend the range between landing strips. The FAA brought in a new set of regulations known in the trade as ETOPS, Extended Twin Engine Operations. The ETOPS let twin-engine planes fly routes which would now leave them 2 hours away from the closest airport on one engine, in effect, letting them fly the North Atlantic. It was no coincidence that the deregulation push coincided with the introduction of Boeing's powerful new twin-engine 767. The 767 cost less to make, less to buy, less to run. It needed only 2 pilots on the flight deck. Its larger older brother, the 747 known to all as Jumbo, carried more passengers but also cost a lot more to operate. For the airline industry, 2-engine planes, like the one we're taking across the North Atlantic, meant a huge saving and therefore made a lot more money. And making money is what helps airline presidents sleep at night. Seemingly Air Canada's president, Robert Milton, sleeps very well.
The 767 is an extremely profitable aircraft for us, and it's incredibly versatile. We have 29 of them, and if you look at the roles that they fly operations as short as Rapid Air, Montreal to Toronto all day long, and as long as a route like Toronto to Tel Aviv, which is about 12 hours nonstop. So if you look at the capability of the aircraft and its size, which is great because you're not out chasing 400 passengers for every flight, you can get away with just chasing the top 200 paying passengers on any given route. The aircraft is an absolute moneymaker and a great airplane.
Now fully half the flights between the east coast of North America and continental Europe take place in Boeing 767s. Dave Anderson at Boeing in Seattle was one of the executives who helped sell the concept and the plane.
I think the biggest hurdle to applying the 767 to the North Atlantic routes was the perception about two-engine airplanes. Conventional wisdom used to say that if an airplane had 4 engines, it was safer. However, after about 1 million hours of flying, our data shows that two-engine airplanes are just as safe as 4-engine airplanes. Out of the 730,000 flights or so across the North Atlantic so far, we've had to shut down an engine 16 times, and sometimes we shut down an engine as a precaution, not because there's really an issue with it.
Nice to know. In fact, mechanical failure in aircraft is extremely rare. But there is another modern threat to our safety. When Air India Flight 182 from Toronto to Bombay crashed off the coast of Ireland in 1985, neither the crew nor the engines were to blame. But it was a failure of conscience, a failure of humanity. As it was 3 years later when large pieces of Pan Am Flight 103 smashed into the small town of Lockerbie in Scotland, killing 11 people on the ground. All 259 passengers and crew also perished. A small timing device led investigators to an international terrorist ring, but justice has not been swift. In fact, only 4 people worldwide have ever been convicted of bombing an aircraft. So the focus has shifted from prosecution to protection. And at Pearson International Airport, protecting the passengers and crew of Flight 876 means putting a surveillance system in place without letting potential terrorists know just how carefully they're being monitored. Jim Bertram is Director of Public Safety at Pearson.
We do try and create a balance where the traveling public is safe and secure, but it is kept that way by an invisible force or a series of forces that we provide. We do that by layering our security. We have uniformed security guards at access points and screening points. And then we have a number of people who are not in uniform. There are surveillance cameras, electronic devices, keypad doors, magnetic doors, everything designed so that the customer going through feel that they are in a safe and secure environment.
7 airports in a week, and this is the first time.
Sorry, the thing is that I couldn't sit properly. It was very dark.
Anyone wishing to do damage to Flight 876 or any other flight will be seen by one of Pearson's 1,200 security cameras.
Thank you very much. That's very nice.
I gotta wait to turn it off.
Thank you, sir.
But the cameras are not the only piece of equipment they can use. Profiling software is now available, which looks at the method of payment, time of check-in, your final destination. Putting it all together, the software computes the risk of you being dangerous and alerts the security people if it gets suspicious. But the biggest concern for all of us who travel is still the threat of explosives simply being left in or around the airport. It takes constant vigilance.
We look at everything that's unusual with suspicion.
Terminal 2, Terminal Officer Bravo, Security Operations.
Every unattended bag is viewed as suspicious. We isolate the bag.
Got an unattended bag by the public telephones. Arrivals level international just outside of doors A.
Okay, thank you.
We have our own canine unit that is specially trained for explosive detection. They're called in, the police are called in. So you have quite a number of people tied up for a fairly significant length of time on something as simple as a briefcase that's just left behind, or a camera case, or in fact a duffel bag at a bus stop. Security will not be compromised in any way at the airport, so whatever resources it takes will be spent.
The bag turned out to be simply a forgotten computer, which was retrieved by its student owner. But no one knew that. With unattended luggage, no one ever knows for sure. And Flight 876 is edging ever closer to takeoff. At one time, captains and first officers were paired together as a team, but now computers create their schedules based on seniority. Under this system, two pilots flying the same plane across the Atlantic might meet for the first time just before they take off, and might never fly together again.
In my position, where you're a relatively junior with the airline, you get to tend to get exposed to a lot of different things, a lot of different people, different ideas, different techniques, and you get to pick and choose. The downfall of that is because you don't fly with these same people, you also don't develop as far as a crew as you probably would if you were teamed up with the same person for a long length of time, where you know what the other guy's thinking before he even does it. And you tend to get that way with people you work with a lot.
This cockpit, this mass of dials and numbers and instruments, will be home to Jim Guild and Chris Granley for the next 7 hours. The instrumentation on a 767 is a blend of analog and digital. This was the first generation of what became known as the glass cockpits, where video screens replaced dials.
The glass cockpit aircraft can land in much lower weather conditions, therefore the airline experience is a much better operation. You can get your passengers to the destination with a glass aircraft where an older vintage aircraft would not be able to land under those weather conditions.
In the middle of the instrument panels, easily seen by both pilots, are the engine indication and crew alerting systems, the ECAS. This electronic display monitors more than 400 different items concerned with the engines and their subsystems, but it's up to the pilots to check over the standalone traditional instruments like the altimeter, the airspeed indicator, and the vertical speed indicators. Above the instrument panel is the interface for the autopilot. Pilots can now program the climb and descent rate and change any heading and altitude corrections they get from air traffic control. In fact, they can program the entire flight, which makes you wonder why we need them at all.
The new technologies do not take so much away from a pilot's skills, but they move them in other directions. You become much more of a system operator at times than you do an actual hands-on, I'm holding on the airplane and flying right now. You are always flying, whether it's you making an input to the computer or you actually pulling some strings that move a servo in the back of the aircraft. It's the same thing, it's just a matter of how that signal gets to where it needs to be in the end.
The central console, between the pilots, houses the brain of the 767. The flight management system is the main interface between the aircraft and the flight crew. Load the flight plan into it, and it starts to check with all the other onboard computers to find the best way to carry out the plan. As the flight progresses, it's the Flight Management System, the FMS, which will give Granley and Guild a steady flow of information on how they're doing. how much fuel they're burning, what their arrival time will be, and if they're still on budget. A bit like having the company accountant right with you in the cockpit.
Air Canada 876, good afternoon. ATIS is Oscar. Check your gate 105.
Air Canada Flight 876 is now in the final stages before leaving for Frankfurt. In Toronto, the job now is to make sure that we get airborne on schedule and are kept a safe distance from every other plane in the sky.
To Frankfurt.
KLM 692, contact tower now, 11835.
1835, KLM 692, good night.
Controllers in the tower are responsible for instructing aircraft on the ground and giving takeoff and landing clearances. But once a plane actually gets into the air, the responsibility shifts to what's called an area control center.
Canada 464, identified on departure, maintain 5,000.
5,000,
Within a radius of 30 miles, terminal controllers handle both arrivals and departures, making sure there's 3 miles of empty space between aircraft. Their job will end when the aircraft reaches 23,000 feet. It then becomes the responsibility of a high-level controller, who'll merge our flight among the aircraft already in the air and established in their own particular airways.
8824, turn left heading 080, higher at 5 miles.
A departure controller, working the terminal airspace, will be responsible for up to 10 different aircraft at a time. Each of his colleagues, handling either takeoffs or landings, will have about the same. They have to allow 1,000 feet of free airspace between the planes that are leaving and those arriving. And in Toronto, don't forget, they're coming and going every 40 seconds. Arnie Young is a departure controller.
We normally climb him, if he's a jet, to 7,000 feet. And the reason we climb him to 7 is to restrict him below the arrivals that are all descending to 8. So he's climbing to 7, arrival aircraft descend to 8,000 feet. Once they are clear on radar, the departure controller then can then climb the departure to his en route altitude, or in our case, it's to flight level 230, and then hand him off to the en route controller and switch the aircraft. And it's that simple as far as departures are concerned.
Nice to know it's simple. Of all the jobs in air traffic control, this is considered the most demanding, the most stressful. Luckily, Arnie hasn't quite grasped that.
Martiner 812, you're by everybody. Climb now, flight level 230.
Everybody says to you, oh, air traffic control, there's a lot of stress in that job. I think there's a lot of stress in everybody's jobs. There's a lot of stress being a housewife, staying at home with 2 kids.
Beaver 92 heavy, identified, turn left heading 150, maintain 7,000.
It's busy all the time, but we, as controllers, we thrive on it being busy. We like to work a lot of traffic.
Beaver 92 heavy, Toronto Center now 124.92.
If 2 aircraft come within close proximity of each other, or if there's really bad thunderstorms, that can be stressful in our part of the job, but there isn't continual stress in that job. You wouldn't be able to do it for a long time.
By the time Flight 876 lands in Frankfurt, we'll have passed through at least 24 different traffic controllers in North America and Europe. We've already consumed the talents and skills of perhaps 100 individuals we haven't seen, from maintenance and security through planning and flow control. But now at last, it all comes down to this. We are finally ready for takeoff. Flight 876 is about to carry us into the night sky and over the Atlantic. Just another one of those 50,000 commercial flights that take off and land around the world every day. It happens so often that we're inclined to forget the simple wonder of it. A man-made machine, a miracle of modern technology, about to launch itself and its human cargo into the heavens.
Air Canada 876, exactly.
Air Canada 876, runway 24 left, taxi via Delta, altimeter 3026.
Ladies and gentlemen, we should be departing very shortly. Would the flight attendants please take their positions for takeoff? Thank you.
As you are cleared to position on the runway, you're thinking about an emergency procedure that you may have to carry out, so you're making sure that you've got everything straight in your mind about that.
Every takeoff is exciting, just like every landing is exciting. And, you know, to be probably clinical about it, statistically speaking, you know, there are accidents that happen, and most accidents happen during the takeoff and landing phase. Engine-related problems actually happen mostly on takeoff, because here's an engine that started cold here just a few short minutes ago, has now been asked to provide everything it's had. It's got in there, or most of it. Things can happen there as well. Those are all things that are going through your mind at the time.
They're advised, ADI and HSI. Checked. And checked as well. Packs are auto. Transponder lights to go.
Here we go, 155, 159, 164. Runway heading to 1,000, left turn 235, maintain 5, noise abatement plan.
Roger.
Quite often the actual clearance for takeoff is relatively rushed because there's somebody on relatively short final, so you might often do a rolling takeoff and finishing the checklist items opposite take the runway.
Air Canada 876, Toronto Tower, clear for takeoff, runway 24 left.
Takeoff 24 left, Air Canada 876. 3000. TARA. Lights are on before takeoff check is complete. EPR.
You are beginning to advance the thrust levers to get power on the engines. You hear them begin to accelerate. You're listening to the sound of them. You know what the sound should sound like.
And here you're flying 400,000 pounds of metal, hurling it down, you know, a 2-mile runway, and you wonder how it all happens sometimes, and whether things are going to work the way they're supposed to work.
As you accelerate through 100 knots, the pilot not flying will call 100 knots off his airspeed indicator.
At 100 knots, when you start to think about maybe I shouldn't be continuing this takeoff.
100. Roger.
Things are getting pretty serious, because a high-speed reject is almost always an emergency unto itself, let alone whatever problem caused it.
Next is the pilot not flying calling V1, which is the refusal speed.
At V1, we have to be initiated immediately, rejected takeoff, or if we delay beyond that and decide to quit, now we don't have enough runway to stop.
You take your hands off the throttles at that point, and the next call is VR for rotate. And you rotate the aircraft nose up, and you take off.
Positive rate, gear up. Heading select. 235, sorry. 235 now.
Air Canada 876, clear to 5, departure 2888.
5000, 88, Air Canada 876.
It's just amazing every time you get in the air, and especially how well the aircraft performs, considering how heavy it is, but the engines put out a huge amount of thrust, but you still have to wonder about it every time it happens.
Departure, Air Canada 876 Heavy with you through 2,400 for 5,000 off left side.
Air Canada's 876, radar identified on departure, maintain 5,000.
Maintain 5,000, Air Canada 876.
As we climb to 23,000 feet, we'll head over Messina, New York, where we'll become the responsibility of the Montreal Area Control Center. They'll be with us as we change airways and head to Saint-Jean, Quebec, and then out to the North Atlantic.
230 VNAV. Roger.
In just under half an hour, we'll have burned 10% of our fuel as we get to our cruising altitude of 35,000 feet. Back on the ground, another group of passengers are arriving, and the same network of people and technology is swinging into action, preparing flight plans, checking weather, loading fuel. Ahead of us, an entire new congregation of skills are about to adopt us, shepherding us at first over the ocean, and then through the busiest airspace in the world as we arrive in Europe. In Newfoundland, in Ireland, in Britain and Germany, air traffic controllers know we're on our way. We've already become part of their daily workload, a speck of humanity on a radar screen. They know where we are, while we, for the most part, are oblivious to the roles they will play in protecting us while we're in the sky. Later, as the night seeps in, we'll try to sleep. But for the moment, we are with Charles Lindbergh, rising to leave the new world for the old, rising into the dark. It'll be 7 hours to Frankfurt. Flight 876 is airborne.